Assalamualaikum warahmatullahi wabarakatuh. My name is Syahira and I'll be explaining about this RC series circuit. So in this RC series circuit, the goal in this experiment is to charge up the capacitor. So as you can see, I put the voltage marker at the capacitor because we want to measure the voltage or potential difference in the capacitor. As we simulate the circuit, I'll open the graph. As you can see, the voltage is increasing rapidly, and there is one time that the voltage will be decreasing rapidly. The voltage increasing rapidly, which represents the capacitor is charging, while the decay represents the capacitor is discharging. In this experiment, we can also record the time constant. The step is we need to choose any point, then we choose this toggle cursor, then press this mark lever, and it will come out this. So as you can see, it is 2.2858 volt. This time constant shows how long it takes to charge up the capacitor. The purpose of this experiment was achieved because the charging and discharging was observed in this expected result. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So my name is Iryani Binti Rodzi. So I'm going to explain for part B RSC series resonance circuit. So for this series resonance circuits, I'm using a Pspice simulation to construct the series circuit. For the series circuit, I'm using a V sign as a V source, capacitor with a value of 0.33 microfarad, inductor with the value of 2.4 millihenry, and resistor with 15 ohm, and it also connected to the ground earth. Okay, for the VAC, I'm going to have a value at DC as 0 volt, SC as 1 volt, V off as 0 volt, V amplitude as 1 volt, and here I'm using a frequency of 10 kilohertz. So after the series resonance circuit I had constructed, so here is I'm going to insert a probe to indicate the current at capacitor, inductor, and resistor. So the next one is at before we simulate the waveform, we go to the setup analysis. So we're gonna enable for AC sweep and bias point detail. So at the AC sweep, we using a sweep type for linear, and the sweep parameter I started the frequency from 10 to 10 kilohertz, the M frequency, so that the waveform will started from 10 to 10 kilohertz. Okay, after we had settled down all the parameters, then we started to simulate for the result. So here is the result for the series resonance circuit simulation. So before I explain about the waveform, so we need to plot for resonant frequency and half power frequency F1 and F2. So the first thing first, we go to trace, then go to cursor and display. So it will display the cursor through the waveform. So I'm going to indicate the resonant frequency. So here is the cursor. So next one, we need to plot or mark the resonant frequency. So I go to plot, label, and mark. So here is the resonant frequency. So the second one is half power frequency F1. So next, go to plot, or here, we can go through here. So here is the F1. Next is F2. mark. Okay, after that, okay, I'm going to move for a better viewing. So the waveform only amplify until 10 kHz as before. For the analysis setup, I started to from 10 to 10 kHz. So we could define here as a user defined at y-axis. Sorry, x-axis. So here user defined to 10 kHz only. Okay. So here is the waveform. Okay, for the result simulation, as you can see, this is the waveform for the current at inductor, capacitors and the resistor. So this waveform is actually obey the Ohm's law for a series circuits, whereby I through the series circuits will be equal. So as you can see, all the three currents through the capacitors, inductors and resistor have the same waveform throughout the circuit. Then the next one, as we can see here, is F1, Fs, F1 and F2. So from the waveform, we could see the bandwidth and quality factor. So the bandwidth for this waveform is a bit wider, as the quality factor will be low for this waveform, as the quality factor for this waveform is actually 5.68, that is less than 30. So it have a least selectivity for quality factor in this series resonance circuit. So series resonance circuit will have a least selectivity than a parallel resonance circuit. That's all from me. Thank you.
Assalamualaikum, my name is Aishah Binti and I will show on how to construct experiment part C case 1. As we know, this is an RL series circuit. Note that V sign is set to 240 RMS and 50 Hz. First, we construct the circuit as shown in lab sheet. Then, we set the AC and V amplitude to 240. Also, the frequency to 50 Hz. Next, change the value of resistor to 343 ohm according to the lab sheet. Using inductive reactance formula XL equal to 2 pi FL, the inductor value we got is 0.7639. Finally, put the voltage and current probe to the component we want to measure. Run the simulation and mark the waveform. Compare the answer in the theoretical formula and what we simulated. It has some slight difference due to error occurred during the simulation.